On June 26, 2020, at 12 a.m. GMT, a CoSpace Rescue Challenge map was issued to iCooL participants from around the world. All participants were given 24 hours to develop AI strategies to solve the same challenge. In CoSpace Rescue Challenge, teams are required to build a real robot, develop and program appropriate algorithms and strategies for both real and virtual autonomous robots to navigate through both real and virtual worlds. Additionally, they have to search and collect objects while competing with another team's robot that is also searching and collecting objects in the same real and virtual worlds. During the challenge, the robot needs to overcome barriers, avoid traps, and swamps. If the robot successfully makes a deposit, the points of the objects deposited will be doubled. For University and U19 category, the CoSpace server will send the robot its own coordinates while the robot is searching in the virtual world. The location information can be used for the development of AI algorithms and strategy such as path planning and search algorithms. Additionally, for University and U19 categories, there are signal block zones which are surrounded by pink dotted lines. When a robot enters the signal block zone, its coordinates information will be blocked. The winner of the challenge will be the robot with the highest points.
Good day to all judges. This is my self-introduction. So, a bit more about me. My name is Elliot Koh and I am from the School of Science and Technology, Singapore. My school is based in Singapore and I participated in a CoSpace Rescue Challenge, specifically under the Under 19 category. I have been a member of robotics at APEC since 2019 and that was when my robotics journey started. So, here are some of the strategies I used in this time's competition. First, I set up a foolproof trap, border and signal block detection system. This prevented the robot from venturing into such areas which might severely hinder the score. This also allows for a less worrisome time in programming other features such as picking up the other points. For example, when the robot encounters the pink or yellow border, it will instantly swerve to avoid entering the zone. This ensures that the robot does not act unexpectedly in these zones and lose points. Also, when it reaches the border, it will do a roughly 180-degree turn, which ensures the robot will not get penalized or frozen. My second strategy is to use the swampland and wall for point depositing. In the map, we can see that the swampland is positioned near the orange scoring zone at the southwest corner of the map. I leverage this by ensuring the robot always makes constant small advances towards the right when the swampland is detected. This will allow me to easily enter the scoring zone and deposit everything I have on me so as to ensure not to miss scoring opportunities. Similarly, the wall along the northeastern edge was also used to so-called align the robot using the ultrasonic sensor. By making an edge in and out, such as during a PID sensing, it will increase the chance of entering the depositing zone to ensure maximum point deposition. My third strategy was to use a color range instead of using an exact color. This provided less room for robots to easily or accidentally miss spots, which might reduce the total points collected. My fourth strategy was to use different turning values for different colors, such as yellow and pink. This customization suits the different colors due to the playfield design and allowed me to turn at appropriate angles for different spots so as to ensure my robot does not get stuck, as well as to ensure that my robot can travel more areas in less time. Finally, I will be talking about my learning experience during this challenge. So some of the challenges I faced was that it was the first time using a robotics simulator, so it was a very new environment for me. However, I managed to overcome this challenge by practicing many times in the environment prior to the competition. This allowed me to be more familiar with the system and not have problems with the software on the actual day. Secondly, the challenge I faced was that the simulation acts very similar in real life, such as the motor randomness that happens on occasion. I overcame this by programming in a way that allows for a certain degree of inaccuracies, so that my results will not differ that much even when there are slight inaccuracies. The third challenge I faced was that I felt dejected by the failures. It was very depressing because sometimes, even though I thought I did the task correctly, it still felt the robot still did the wrong thing, and it was very dejecting for me. However, I managed to overcome this by taking constant breaks during when I felt mind blocked, and this allowed me to keep a fresh mindset. My overall experience was that I found it interesting and it was something very new to me. It was a very fresh experience and it was very insightful. It also inspired me to look into the field of robotic simulators and how they might be improved. If I could sum this whole experience in one phrase, I would say it was beautifully imperfect. The inaccuracies in the software felt realistic, ensuring an authentic and lifelike experience while programming and testing. Thank you for listening to our presentation, and I hope you have a great day.
We load map data into our algorithm. It contains data about walls, areas of objects, and color of the floor. For work with map, we use Dijkstra algorithm. Each zone has its own value. The cost of each zone is shown on the screen. The algorithm constructs the shortest road and starts moving. After reaching the necessary point, he changes it and going to another point. In the exposed area of object, the algorithm puts a random point and moves to it. It moves through the zones of each color until it's found the request number of objects. Then he puts a random point in deposit area and going to this. After the appearance of a super object, the robot travels to it. After that, it begins to collect all the other objects necessary for the appearance of another super object, and the cycles begin anew. So this is our algorithm. Thank you.
And off we go! In this demo game, we will minimize any manual intervention. Red robot travels out of the boundary, system resets it back to the field and freezes it for 10 seconds. Red robot travels out of the boundary, system resets it back to the field and freezes it for 10 seconds. Blue robot is depositing. Red robot travels out of the boundary, system resets it back to the field and freezes it for 10 seconds. Blue robot is searching in the blue special area. Any objects picked up in this area will double in value. Red robot is full. Red robot travels out of the boundary, system resets it back to the field and freezes it for 10 seconds. Blue robot is full. Red robot is depositing. Red robot travels out of the boundary. System resets it back to the field and freezes it for 10 seconds. Blue robot needs to make a deposit before it can continue collecting. Red robot travels out of the boundary. System resets it back to the field and freezes it for 10 seconds. Blue robot is depositing. Red robot travels out of the boundary. System resets it back to the field and freezes it for 10 seconds. Blue robot is depositing. Red robot travels out of the boundary. System resets it back to the field and freezes it for 10 seconds. Blue robot has a set of red, black, and cyan objects. It can generate a super object. Blue robot is in the swamp. Speed is restricted. Red robot has a set of red, black, and cyan objects. It can generate a super object. Red robot travels out of the boundary. System resets it back to the field and freezes it for 10 seconds. One minute left. Red robot is full. Red robot travels out of the boundary. System resets it back to the field and freezes it for 10 seconds. Red robot travels out of the boundary. System resets it back to the field and freezes it for 10 seconds. Red robot travels out of the boundary. System resets it back to the field and freezes it for 10 seconds. Blue robot wins this challenge. Congratulations!